Okay, so now we just talk about the stuff that is other considered other issues. Alright, so we are talking about something that is a bit not related to your whatever stuff you're talking about just now. We're going to talk about other stuff. So one of the issue is actually talking about charge pumps and switching supplies. Alright, so there is two approaches when you talk about charging. Alright, or maybe charge pump is like maybe your battery charger or your battery, so to speak. I don't know, but anyway, it's talking about how to store your electrical energy. Alright, whether in terms of an inductor or in terms of a capacitor. Okay, so in this case we talk about charge pumps that uses a flying capacitor. So the capacitor can fly. Alright, in the sense that, alright, when you charge the capacitor, alright, you charge it in parallel. Alright, so you have a voltage. You know that when you have a voltage, alright, the voltage is the same for parallel. So therefore you charge the voltage parallel for the capacitor. After you finish charging the capacitor, then you bring it over to this side. You connect in the parallel so that it can be connected to your load. So to a certain extent, you can see that your capacitor is macam like a battery. Alright, so you can have two batteries connected in series to power up your load. So when you charge, you put it inside this charger, so your charger can charge in parallel. So 2 or 3 or 5 batteries can all charge together at once. Alright, so this is just a charge pump. So your capacitor can fly is because you can fly from when you charge already finished, then you can fly to apply in the load over here. So that's why it's called the flying capacitor. And the switching, alright, I think, so in other words, these two systems, this system and this system, are all together at once. Okay, so whenever it turn on, alright, this is more in depth, so we will not go through it. I also don't know how to go through it, but anyway, this two system, alright, that we have gone through is together at once. Alright, they are placed in the same position. Alright, they're placed in the same physical position. Meaning, if happen that if I have if let's talk about something else. Let's talk about your house phone. Your house phone, normally you have a charger over here, right? You have two batteries and then you put inside the charger. So the charger will actually charge your battery. So when you charge the battery, it is charging in parallel. Alright? But when you take out your phone from your charger, alright, it supply a series voltage into your phone. So I didn't change any of the battery's position, right? So it's the same thing over here. They are connected. This just only talking about their connections. But as long as you didn't connect onto the charger, or as long as you didn't connect to the charger, then it is so. In other words, when you connect to the charger, it's this picture over here. So you'll charge your battery, and then if you take out from the charger, it will supply voltage like this. Alright, so these are the things. And this switching is using MOSFET. Alright, the MOSFET concept comes from your previous understanding from your lecture 10, driving a load. This is one of a transistor. Alright, it's a MOSFET. So it's the same thing. It works by putting in, instead of current, it takes voltage. If you remember, the MOSFET is controlled by voltage, not current, rather than current. For the bipolar transistor or the Dielectric pair, they are controlled by current. Okay, so if you are using MOSFET, it is controlled by voltage. Okay, so therefore the application for your MOSFET can be seen over at this application over here. If you want to know more about MOSFET, then you can just watch this video, or you can watch these 2 videos or these 3 videos. Okay, it's talking about all the transistors, if you happen that you don't know what I'm talking. Anyway, so this is the issue of charging and switching power supplies. Okay, and then next up is the condition called the brown out. Okay, so for example, when you have a power supply, how should I draw this then? Imagine you have a memory space inside a certain system, maybe your computer. Alright, so you have a power that is connected to your computer, alright, that has memory. And then you are downloading a data from some other space. Alright. Although your computer may be on, to a certain extent your power wouldn't be always constant. Alright, so for example, this is your your time, this is your power. Alright, your power wouldn't always be like this. Alright, you may have certain time when it is like this, and then it zoom, and then it comes out again, and things like that. So at this particular zoom goes down, the data that is coming at this particular time is gonna be affected, right? Because at this time, it may not take in full data yet. Alright, you may not take in whatever data that you want, or maybe some files that you want to download. Alright, so there's certain issues regarding this thing, and this may actually cause your file to be corrupted. Alright, and corrupted issue is very troublesome. It's because you don't even know where the data is, because there is so many data out there. When you download a certain data, it's talking about many zeros, about 1 million or whatever data. So if you want to find a particular one corrupted file, you're gonna find until tomorrow. Alright, nonetheless, leave room that I may be wrong. Okay, so I may still be wrong, but anyway, at least this is something that talks about the brownout issues. Alright, so this is a brownout, and it's very serious if it's not detected. Alright, because of corrupted data. Alright, if other unaffected parts attempt to use this corrupted data, then other parts will also be corrupted. Alright, so as you can see, there is a chain reaction. So if the corrupted parts is corrupted already, and other things use these corrupted parts, then other more things will be corrupted, and you sell out, die already. And at the end of the day, your RAM will be affected. Alright, because your RAM is talking about the taking in, because if you still remember your RAM, don't know what the hell is RAM, then you can just watch this video. Alright, chapter 2 microcontroller. You'll briefly talk about what is ROM or RAM. The RAM is a volatile system. When your power is gone, the data is gone. It is used to process your data to perform certain stuff only. Right, while the ROM is like your D drive, the drive that you can take in memory. While the volatile ones is the purpose is to transfer one information to another. Alright, things like that. Alright, so the RAM is working in this manner. So if you have corrupted data all along, and you actually requires more, in a certain sense, the corrupted data may requires more work from the RAM, and this will actually cause a lot of issues. Okay, sorry, my fault. Alright, ignore what I've just said for the RAM, and let me repeat again for the RAM. Okay, because when you have a power loss, for example, if you have power loss, where am I? Damn it, hold on a while. As I say, if you take a look in this diagram, this is the time, this is the power. So imagine you have a power loss, boom, and then come out again. Okay, this particular power loss is gonna restart your RAM. Okay, because when your power is gone, your data is gone. Alright, so your RAM is gonna be restart again, because you know that the RAM is working when your power is up. Alright, so when your power is gone, you'll refresh. You will not store any memory at all. It is storing memory when your power is up. So if there is a certain power gone in this case, alright, the RAM will so this is the RAM at this point, and then at this point when it goes no power, this RAM will restart. Alright, so it will restart, and a new system of RAM will come out. Alright, and you'll process new level of data. So at this particular point, your data has no information, right? Because your RAM didn't do work at all, because there's no power to allow your RAM to transfer data from your whatever internet downloading or whatever to your computer. Okay, so therefore this particular thing is going to cause your RAM not to do any work. Alright, and therefore it will cause your corruptions to your data. Okay, so this is a better understanding, because after I read, I think this is better. Alright, so nonetheless, I may still be wrong, so be careful of that. And as such, this particular file that is being corrupted already due to this power loss issue, where am I? Yeah, due to this power loss issue, if this data, if I call it data A, alright, if data A is being used by other parts of the memory, or it happens that if I have a certain other device within the same hardware, so if A take in data A, alright, takes in from here, so data A is coming from here now after I download it from internet. Alright, this data A will be used from maybe device Coco. Alright, this device Coco. Alright, so device Coco will take in data A and you will process. But however, data A got problem, so you'll corrupt the data from Coco also. And after that, the Coco will generate certain data, and other system will take in the data from Coco. and other system will be corrupted again. So these issues cannot be tracked very well, alright, because it's like a virus, not virus, but in the sense that it gives you problems. Alright, so this whole thing is called the brownout. Okay, so I hope at least you give a understanding now. So in order to counteract this problem, you have a microcontroller that have a brownout detectors. Alright, so it will detect the brownout issues when you have a low voltage inhibitors. So there will be a certain detectors such that when you send, there is a low power. Alright, this low power that correspond to whatever data, maybe we say data A, this data will be eliminated, will be destroyed, so it will not be used. Okay, and that after you delete the thing that is corresponding to the particular data, and that you reset the RAM or reset the whole system, so that the whole system will come out to this place again, and you continue to take in other data. Alright, so whatever corrupted data will not be stored inside your system. Alright, so if I delete the data, alright, then you have to re-download the data again. Okay, but at least you didn't corrupt your other files. Alright, so this is one way to actually help in doing this. Alright, so you can introduce your low voltage inhibitors. Okay, so this is the answer. So in order to counteract brownout, you need to use low voltage inhibitor that force the chip to reset if the voltage falls below a specific value. Alright, so sometimes the voltage may not be exactly falling down. Alright, not exactly going to the zero, but maybe something like this. Alright, but this is still a corruption. This will still corrupt your data. So there will be a certain threshold point where the detector over here will detect. If you reach this point, delete the data. Alright, so this is the thing they are trying to say lah. Okay, so the CM3X does this. So it's like a microchip. So there will also be other integrated circuits. IC is integrated circuit that helps to take care of this issue. Nonetheless, there will be other systems or special power supervision circuitry to ensure that everything works in the right way. Alright, so this is more on the power supervision way. Alright, to allow so this power supervision is to supervise the power such that you can prevent any brownout issues to occur. Okay, so I hope that this is pretty clear. So because this video is way too long, I'll talk about watchdog timer in the next video. So this is something like a part 2 of this other issue series. Okay, so other issues we'll talk about previously we talked about something, but I also didn't write here. So next we'll talk about the watchdog timer. Alright, so I'll just see you there in the watchdog timer. Okay, yeah.